Sometimes statisticians need to go beyond simple random sampling and use more advanced sampling methods. Two of the more famous sampling methods that statisticians use are called stratified and cluster sampling. These sampling methods are based on groupings within the population. I do find that students struggle to understand the difference between stratified and cluster sampling, so that's what this video is going to help with. Let's look at an example. Suppose that we have 600 people in our population, and our researcher or statistician is quite interested in a topic that might alter your opinion based on your age. So they do the legwork and they split up our 600 people into groups of 4, where there's 150 of each of the following ages: 18 to 29, 30 to 44, 45 to 65, and our senior citizens 65 or over. When it comes to stratified and cluster sampling, there is always going to be a grouping component associated with it, where your population is going to be separated into groups. Okay, before we get into these two methods, I want to backtrack a little bit just to make sure everybody understands what we would have done without knowing these methods. So the only sampling method you know of so far is the SRS. So let's ignore the groups for a second and just say, well, what would we have done? We would have taken an SRS, simple random sample, by numbering this population 001 to 600. And let's just, for argument's sake, say that we wanted to sample 300 people. Well, what would we have done? Well, we would have gone to our table, random digit table, right? We would have started picking numbers. So right now we're at 01 to 600. Let's just be lazy here and start on the row 1, column 1. So we would have started picking 3-digit numbers. So this would have been out, that's out. Our first person would be person number 114, then 275, then 368. And you would have kept on going and done that 300 times. Doesn't sound fun, obviously. Probably something better for some computer to do than us to do manually. But what does that actually mean for us in the end? Well, you would end up with 300 in your sample, but you would have no guarantee that you had an even number from each age range. So, for example, you could end up with, 10 from here. We could end up with 70 from here. We could end up with 120 from here, and so forth. So if this is indeed the type of research that's going on that might depend on your opinion in terms of age, so your age might determine your response, then that would not been a great method to use, a simple random sample. So that's why we're not doing that in this scenario, because we'd like to get a better idea of somebody's opinion, maybe based on age. Okay, so now that we know that an SRS is not going to fit our needs, and keeping in mind that we are trying to reach a sample of 300 in the end here, why don't we take a look at what would be required in order to do a stratified sample. So a stratified sample is basically trying to take each one of your groups and do a simple random sample. So I know that sounds a little weird, but that is exactly what we're going to do. So we're going to go to our first group of 150, which is our 18 to 29-year-olds, and we're going to number them 001 to 150. We're going to do the same thing for all of these, but we're going to do it individually as if they're completely separate entities. So obviously you can't do them at the same time or people are going to be numbered the same. So we start with our first group, basically, we know group one. Before we do anything, we number them 001 to 150, and then we have to pick how many we want in the sample. Now, the fact that there's 150 each of these, and we need to get to 300, if we do 300 divided by our four groups, we're going to get 75. So why not get 75 for each group? So what would we do? We, just like before, we have our number 001 to 150. So we would go to our table, our random digit table. Let's say we're just starting over here. Let's say 6 and 1. So this time 150. So, this is out, that's out. So our first person of our 75 would be 044. We would keep on doing that until it would take a while, unfortunately, but we would keep on doing that until we got 75 people to go in our first group. So 75 of the 18 to 29-year-olds. So stopping there, we would then move on to group number 2 right here, our 30 to 44-year-olds. Repeat the step. Number them 001 to 150. Go into the chart at a different location. Pick 75 people that go here. And we would keep on doing that individually with each group until we got 75 for each. And of course, if you add those all together, that would give us our 300 that we are looking for. Okay, so what are the positives of what we just did? Well, what we aimed to do was to get an equal number of opinions from each age range, and that's exactly what happened. Our age ranges, which in any problem would be the groups, are well represented. So this seems like exactly what our researcher wants to use in order to ensure that we get an equal opinion from all the age ranges. Okay, what about the negatives? Well, this can be a very time-consuming exercise. I mean, if you think about it, we had to do 4 different simple random samples to make this work. And it turns out that with stratified sampling, some of the statistical analysis can also be pretty complex. But generally, without even knowing that, because we're not really going to get into that in this course, it's a time-consuming and costly exercise. Okay, one small thing before we make the transition to cluster sampling. Just remember that there has to be some type of random selection in order for this method to not have bias involved. So in this case, our stratified sample, we had a random selection that occurred somewhere in this area. After we numbered each of the members of each group, we selected them. That must be present somewhere. And that is going to be a big difference between the two sampling methods, is that the random selection occurs in a different location. So keep an eye on that as we move on to our cluster sample, which is here. So cluster sampling. Keep in mind that our goal is to get to our 300 member sample. In order to accomplish this in a cluster sample, what we're going to do is we're going to label each one of the groups. We'll call them A, B, C, and D. The key is when you have a cluster sample, you randomly select groups as opposed into a stratified sample when you randomly select people within the groups. So therefore, what we need to do in order to accomplish that is we're going to have to number our groups. So we'll number them, 1, 2, 3, and 4. Or in other words, number them 1 to 4. Now, keep in mind, if we're trying to get to our 300 people and we're randomly selecting the groups, then it would only take us 2 groups to get there because each one is 150. So therefore, we're going to go into our random digit table. Let's pick some location. Let's pick 5 and 26, let's say. So we would start here. 4, so we're numbering them just 1 to 4. So 4 would be a hit, so our first group would be 4. 8 is out of there, 7 is not there, and 1 would be our other group. So we would go into our groups and we would say that group 1, which is letter A, and group 4, which is letter D, those would end up being the age groups that we would have into our sample. So we would then take our 150 of our 18 to 29-year-olds and our senior citizens. We would add them together and we would get our 300 people that we need for our sample. Okay, so just to review here, each of these require random selection, stratified and cluster. For stratified, we had to randomly select the people within each group, whereas with cluster sampling, we had to randomly select the groups themselves. And when we select those groups, we use every member of the group, 150 for each, and put them together to get our full sample of 300. Okay, so let's talk about positives and negatives. So for positives here, this is a lot less time consuming and costly because you'll notice that we were actually able to randomly select this within 10 seconds, 15 seconds, whereas this, we were able to maybe pick 2 people from our first group of 75 each. It would have taken forever to do that. So therefore, this is less, that's not an S, less time consuming. And costly. So it wouldn't take too long. You don't have to pay somebody to do all that work. But the negative, well, what was the point of this to begin with? It was to get an equal amount of opinions from each age range. The problem is we've literally just left out these entire groups. So if you recall, the key word here is underrepresentation. You want to say of some groups. That is obviously not ideal for what the point of this exercise was. Hopefully you can see how the choice between these 2 sampling methods might seem obvious in one standpoint from somebody maybe just learning this. I find that students are like, oh, we got to do stratified. It tackles everything we need. The problem is, in the real world, money and time talk, right? So it's not as easy a decision for a researcher as you might think. You only have so much money in the budget, so sometimes decisions just have to be made, which is why both of these methods are around and are legitimate random sampling methods.